Okay, good afternoon or good morning, everyone. Thank you very much for attending my talk. And so today what we're going to be discussing is how do we manage systems at scale? We've all come across talks discussing how amazing containers are and how that's going to be the future, how DevOps is going to transform our lives and have this great communication between teams, and how Kubernetes is the savior of all of our deployments. But in here, we're going to discuss, okay, what are the realities? Once you have Kubernetes in place, what are the things you need to start considering? What are the problems are you going to start coming across? And how can you potentially solve those particular problems using a technology called Service Meshes? And so today, we're going to focus on communication. So how can our services communicate safely and securely between each one? How can we then scale that out? And how can we ensure that we have security as we continue to scale out our systems across multiple teams and across multiple clouds? So my name is Ben Hall. I'm the founder or co-organizer of a meetup called Istio London, Istio being one of the service meshes that we'll talk about today. And I'm also the founder of Katacoda, which you may have come across in various different talks this week, which is an interactive learning platform for software developers. And so in your browser, you get given a live environment, everything which you need from a Docker daemon up to Kubernetes, up to Istio, is all there, pre-configured or set up. So you can play and you can explore without having to download or install anything or worry about breaking your dev machine. And it's all available for free. And not only do we give you free infrastructure, we also give you step-by-step instructions about how you can solve certain problems, like how can you run containers, or how can you deploy Kubernetes, or as we'll see today, how does Istio and Service Meshes work? And so what are we going to talk about? What are we going to discuss in this talk? So we're going to start with what is a Service Mesh 101, why is it important, and why is everyone talking about them, or why is everyone starting to talk about them? We're going to introduce the concept, introduce Istio, which is a service mesh from Google, IBM, Lyft, and various other people which they're collaborating around. And it's probably the most talked about one at the moment, but there's various other service meshes that exist, and we'll compare what benefits each one of those have. And then we'll look at the realities and look at what benefits having Istio in place brings. So how can you control traffic between your services? How can you increase reliability? Failures always happen, so how can we make sure that we remove the risk of those occurring from a user's point of view? How can we start observing what's happening? So if things do go wrong, how can we make sure that we find where that happens? And then finally, a little thing called security. And the reason service meshes exist is because as we all start deploying these microservices, we have all of our systems talking together, and they become increasingly complex to manage. They become increasingly difficult, and if we're not keeping a very tight control over how we manage this complexity, it can end up becoming a spaghetti of various different services which all have dependencies on each other, all of which are undocumented, which can't be controlled. And if something goes wrong, then it's trying to find a needle in a haystack. Like there's too many things where potentially the failure could have occurred. We don't have any insights into which services is going wrong. And so we can't dot around and panic and try to put out fires and have fun until we find the correct ball which we're looking for. And then once we actually deal with this, there's other components that we need to start thinking about. Like if we're dealing in a regulated environment, or if we're dealing in something where we are sensitive about security, how can we make sure that the components that we have in place are the components that are actually the ones which we're meant to be talking to? So how can we make sure that someone hasn't done a man-in-the-middle attack and said, hey, I am your database, please send me all of your data, when in reality it's some exploit service that someone has managed to put in the middle. And so we can use things like TLS and mutual TLS to ensure that both sides are correct. But this is not the easiest thing in the world to get set up. And so now our infrastructure and our applications need to understand how to manage certificates, which is not the most fun activity in the world to develop. And once we have certificates, we now need to worry about them expiring. Like, how do we rotate them when that expiration comes? Do we have an automated system in place, or do we have a calendar notification in someone's dev calendar and they leave the company and then the year ticks over and then it's like, oops, everything's suddenly gone wrong, which has happened to many companies. like authorization, so how can we make sure that our web application is allowed to talk to the service it needs to, but not allowed to talk to everything in the world. So if that web app does get exploited, then people don't have a direct line to our database, for example, and we have some barriers and some blocks in the way. And then things like retry logic, if something goes wrong, what happens? How does our application deal with that? And so now a very simple microservice has grown in complexity to handle all of these edge cases about how does it run in reality. And the whole point of microservices is that they should be very small, very focused, but if they need to understand all of this other infrastructure level concerns, it's going to become bloated, it's going to become hard to manage, and it's going to become just lots of duplicated code, which is just noise and gets in the way. And so what we want to do instead is let the infrastructure do its job. Let the infrastructure manage all of these concerns and let our microservices and components deal with their responsibilities and nothing else. And this is where a service mesh comes in. So a service mesh is a dedicated infrastructure layer for making service-to-service communication safe, fast, and reliable. So it generally sits on top of something like Docker Swarm or Kubernetes, and it adds an additional layer. It builds on top of what that infrastructure provides and adds this additional level of functionality, which you then build on top of yourself. And one of the creators of a service mesh said, if you're building a cloud-native application, you need a service mesh. Now, take this quote with a pinch of salt, because they are a creator of a service mesh, so they kind of have a vested interest in every cloud-native application having one. But the principle does hold true. If you're following this cloud-native principles of being able to run reliably across multiple clouds, making sure that you're building on top of Kubernetes, a service mesh is something that you should consider and then decide whether it's right or wrong for your application, depending on your risk model, depending on the type of applications you're dealing with, depending on your security requirements, etc. And then you can judge or pick which service mesh is correct, and that's what we'll look into. And so at the moment, most service meshes are tied around Kubernetes. So Kubernetes is very popular. It's a container orchestrator. So it helps manage running of your containers in various different cloud platforms or on-premise with things like OpenShift and other Kubernetes distributions, and in the cloud with things like AKS, EKS, GKE, and all of the other fun acronyms. And the design and its capabilities is that it lets you worry about defining what your applications should do and not worry about if something goes down, how do we then bring that up? Or if we lose a node or if we lose a data center, how do we ensure that we still have capabilities and capacity within our infrastructure to ensure that everything is working reliably and correctly? And so if we have a quick look at a very 101 demo for those who have not come across Kubernetes before, I'm going to very briefly just spin up a Minikube cluster. So Minikube is a software which will help you spin up a Kubernetes cluster locally. So it's used for development time purposes, so you can try things out locally in a very complete way, and then you can then learn everything which you need to do and then push it into a more advanced offering, like a cloud provider, for example. And what this will do is it will go through, and if you're running this locally, it will set you up a VM. In Katacoda, it's just doing everything as containers. It downloads all the components, so we can see it's downloading Kubelet. Kubelet is kind of like the Kubernetes watcher. It will initialize all of the components that are required, and it will make sure that everything which the system needs to be running is running. It will also sit there and listen to requests. So if Kubernetes say, hey, you are a node in the cluster, it's your responsibility to run this container, it's a kubelet which will then kind of ensure that the proxy is sitting there listening to that request, and then the proxy can handle making it. With Minikube and the latest version, it uses kubeadm, which is a great way to bootstrap a cluster, ensure that everything gets started, everything's configured correctly, it has all the right permissions in place, and then after a few seconds, you have a Kubernetes cluster running locally. So you can say, like, get nodes, and this will go off and say how many nodes in a system. This is just for development, so we have a single node. But you could imagine in production, you could have tens, hundreds, thousands of nodes depending on your requirements. And then we can kind of tell Kubernetes to run certain workloads. So we can say like run something called like a HTTP server, point it to a Docker image or a container image, and say like HTTP server. Ignore the fact that I can't remember the new syntax, what they've changed. But this will now tell Kubernetes we want this HTTP server running. Kubernetes will go off and schedule that workload. So it can say like get me the deployment. And it will say like cool, we've got our deployment. It's called HTTP server, because I can't think of a more creative name. We've requested one instance, so we want one of this application running. And this is running as a pod. And so now Kubernetes is managing that lifecycle. If that pod crashed or the application crashed, then Kubernetes would detect that, bring it back to life. If we need more capacity, then we can say scale our deployment. And we want replicas to equals 5, if we actually tell it which one we want. And now it will go off, and if we say like what deployments you have, we'll see it slowly starting to scale them up. So we've got 2 already. We've wanted and requested 5. We now have 5 available. And we have our 5 pods running. So we now instantly have scaled out our application. And then we can start sending some requests to it and having everything working. Now, in a very simple way, this is great. We have our applications running, but we want to scale this out and deal with the complexities of that involved. And this is where we have our service mesh. So there's various different service meshes in place, which we'll discuss. The one, oops, wrong button. Present, not in presenter view. So the nice little sailing ship is Istio. There's like Aspen Mesh, which is an enterprise version of Istio built on top of it. Linkerd, which is an alternative. It's much more lightweight, potentially simpler to get started with, a bit more focused. Thank you, kitchen staff. And HashiCorp Console, which you may be using for various different service discovery, now has service mesh type functionality in place with Console Connect. And so HashiCorp are also moving to this service mesh approach. And there's many others which are fitting into this. So if you want to explore and see which ones are available, then you can go to the cloud-native landscape and see what's there. So let's deep dive into Istio, because I think this is the most comprehensive. It's got the most various different types of functionality, and you can then see what's possible. And if it's too much, you can then look at alternatives like Console or Linkerd, which is a bit more focused on particular areas. And so there's 4 key responsibilities that Istio is trying to drive for. So allowing you to connect services. So if I've got a web application, allowing me to discover and connect to an API that may be available within the cluster, a database, for example, based on what it needs. And within this connect, it actually controls how that connection works. So we can start introducing limits, like security limits, to make sure that only certain things can talk to other APIs, or only things within project A can talk to themselves, but they can't escape and kind of talk to things outside of their control within different projects. But we can go deeper to that. We can go and start setting rate limits. So if we know that an application is particularly problematic at high load, we can ensure that actually we never send more than 100 requests to that service at any point in time. And we can manage that at the infrastructure layer instead of having to have our application deal with that. Particularly useful if it's a black box system which you don't have any control over. And we can apply policies, we can try control and understanding about where our system is talking and who should be talking to each other. But we can then observe, we can then look at what our system is doing, how the system is operating, what errors are being reported. Remember that Istio is living at the infrastructure layer. So Istio sees everything within your system. It sees which services are communicating with each other. It sees how their responses are talking to each other. Like if it's HTTP and it returns a 500, it can then go like, cool, we've got some new errors. Should we be raising alerts? Should we be sending our traffic to another node? Should we be then how should we manage that situation when errors do start occurring. And so these are the core features, but like, why isn't Kubernetes doing this? Like, why doesn't Kubernetes solve everything that we need? And so if we actually look at what Kubernetes offers, Kubernetes is very focused on offering the deployments. Like, we make sure, as we saw, that everything in our application is running. Everything that we need, everything that we've requested is running successfully. If we want to have more replicas, more instances of app, we just tell Kubernetes to scale up, like what we saw before. If something crashes, then Kubernetes will manage that and figure it out successfully. And we can be very declarative. Like, I use kubectl to run our pod, our deployment, but in reality, that's not going to be successful. We don't want people to go to production and go like, hey, run this random application. That's not going to scale. So instead, everything can be defined as a YAML definition with Kubernetes. We can tell it what's important, like how many replicas we need, give it some nice friendly information, like some labels, so we can start connecting these components together, and then give it like what containers we actually need to run. And then we can say, like, how do we want that application to be exposed? Should it be a load balancer? Should it be available to the public or not? And like, Kubernetes is great at doing this, but if we put everything within to the Kubernetes core, it's going to become very quickly very hard and difficult to manage. It can become much more difficult to scale the community around that. The core lessons that you would need to learn when you approach Kubernetes would become much more difficult, and it would become very quickly very bloated and something much more problematic to teach. And so that's why I think it's important that we keep Kubernetes focused on what it's meant to be doing. So managing these pods, so managing how our applications are being deployed, managing what the requirements of those are. Do they need volumes? Do they need to access disks? If so, how do they access those and persist data? And how do we scale that up? The concept of a pod within Kubernetes is sometimes underutilized, but extremely important with how Istio is set up. So most of the time, our pod is equal to one container within Kubernetes. We say, like, hey, run this HTTP server. But in reality, a pod can contain multiple containers which have got their own responsibilities and their own set of focuses. And so within a pod, you can actually have multiple applications running alongside them. They all act as if they're in the same network because they all have the same IP address, so they can communicate, but it allows us to give us some more control and more capabilities. And this is where Istio takes a lot of its, gets a lot of its performance, which we'll see in a moment, which I'm just going to skip over IP tables black magic because it's IP tables black magic, and I just want to do a demo because let's actually see what Istio is all about because we've talked about it. So in this case, I'm going to have a Kubernetes cluster. So we have Kubernetes started. It should be a 2-node cluster. So we have something responsible for the master, which will manage all of our workloads, and we have something responsible for actually running our applications and our deployments. So we're going to deploy Istio. We have a nice, lovely kill straight into bash approach, so being very good with our security model. But what this is doing, it's downloading a couple of critical components. So one is a new command line interface to help us deploy our applications as with the Istio extensions, and it's deploying a set of YAML definitions that actually define what Istio is. So if I make sure that I run all of these commands and we apply, so this is deploying a set of CRDs, a set of custom resource definitions that extend Kubernetes and give Istio some more capabilities. And so we can kind of see some interesting aspects, like we have quotas, we have some metrics, we have various different like virtual services, destination rules, gateways, policies, etc. So we can now start talking in this new definition, which we then will allow us to control how our applications are behaving and working. And so if we run and we deploy the default model, this will now start all of the components for Istio. So this will ensure that everything which we have running, everything which Istio needs, is there running within our cluster. So if we look at what that breaks down to, we have lots more pods, which are just being started. But these are going to manage certain key components. So we have Grafana at the top, so he can start visualizing and having dashboards about what's happening within our system. So again, that key observability point of view within our service mesh. We have a Citadel, which is managing security and doing key rotation and certificate management for us, so that we, as our application developers, don't need to worry about it. Again, it's being pushed down into the infrastructure. Various different other aspects like StatsD, telemetry, tracing, Prometheus, all of these things which are collecting data now about how our applications and how our services are communicating. And then within a couple of seconds, we have that running. And I'm just going to deploy a couple of additional components which just exposes dashboards and makes everything available to us in the details. And what now happens is we have our applications, Service A and Service B. But now when we deploy and have Istio, we also have all of this additional functionality. So we have the control plane, which is Kubernetes in this case. We then have our 3 Istio components on top. So Citadel, which I mentioned, for managing TLS and certificates. We have a mixer, which is there for managing the networking and policies and telemetry, everything at kind of like the lower networking level. And then the pilot, which is managing the configurations, making sure that if we tell it to configure something, then it will go off and ensure that that configuration is in place. What also happens is now, within each of our pods for Service A and Service B, we have this proxy. And so it's using this concept of sidecars and adding an additional container within our pod. So building on that pod concept which I mentioned previously. And this is ensuring that when our traffic or when our services are communicating, it now goes through this proxy. The proxy is called Envoy. It's created by Lyft. It's part of CNCF. It's extremely powerful. It's extremely performant. And so it doesn't offer too much overhead. It's very lightweight. But it offers a lot of control about how our applications can now communicate. So now, when we have this set up, we can do mutual TLS. So we can ensure that Service A and Service B are the correct versions. They are meant to be talking to each other. They are not man-in-the-middle attacked. And people can't jump in the middle and start sniffing network traffic or pretending that they're someone else, which is very important. It can also optimize how our services can communicate. So it can optimize HTTP2 traffic, gRPC, and actually improve the performance of how the networks communicate by sitting there because we've got this more powerful capabilities in place. So we need to demonstrate this somehow. So we're going to deploy a quick application. And I think I have an overview. It's a beautiful enterprise-ready application built by various different teams. So its purpose is to be a book information, very similar to something like Amazon. And we have our product page built in Python. This goes off and calls a review service. The teams are iterating on reviews and adding new functionality all the time. So V1 didn't do anything. V2 added some nice stars. And then V3 added some design capabilities to it by making them colored. It goes off to another Ruby service to get some details. And at the same time, the review service goes off and gets its ratings, like how many stars to display from a node application. It's a very componentized microservice deployment. And now when we go in and have a look at the product page, which we just deployed, again, we've got this beautiful view. We've got all of our book details. We've got our review service being called. And that's now gone off to version 3 because we know based on the colors. And then how many stars to display, whether it's 4 or 5, is based on the ratings. And at the moment, everything is in a round-robin way. So if we hit refresh, we get bounced to a different version of the review service. So in this case, V1, because we don't have any stars. If we try again, we get the V2 response. And so this is giving our users a little bit of a inconsistent experience. But with Istio, we can start to control and manage all of this. So what we can start doing is actually shaping how our traffic works. And we can actually start applying rules about, okay, which users should see which version. And this is where we can start using these extension points that Istio have introduced. So we've got a new virtual service. This is targeting the reviews, i.e. when the product page goes to the reviews, defining which version should actually be handle the request. And we can actually start having very more control over the actual HTTP request. Because we're building on top of the Kubernetes infrastructure, because we have this new proxy layer in the way, we can start inspecting and start controlling the HTTP responses. So in this case, if HTTP has a header called end user, and that value is JSON, then send them to v2. Otherwise, send everyone else to v1. So now if we apply that rule, we should have a much more consistent response. So if I log out, because that's not helpful, so now our production traffic is always going to v1. So we can control which version is actually being responded to. But now, if I log in as JSON, we will always get v2. We can start now releasing in a more controlled manner about how our applications get rolled out. And if you've ever seen any of demos from people like who work at Stack Overflow, and they show you Stack Overflow, you will always notice some hidden additional extensions, like certain features about performance of Stack Overflow, or page load times, etc. And so being able to have these dark releases is extremely powerful in terms of extending functionality or testing things in production. And so now, again, if we log out, we just get back to our production traffic. We can start now shaping, so we can actually say we want to start doing canary releases, for sending 50 traffic to other people, which we'll look at more in a moment. But if we start generating some more load, and we can start seeing some spikes, as I was mentioning, Istio is collecting and seeing all of our traffic within our network. So we can start looking at what that looks like, and what does Istio actually see. So this is the default dashboard that we get out the box, and we can see that it's detected certain parts of our infrastructure without being explicitly told. Based on the APIs that are available, it knows how our system is being deployed. So we have our product page here, and we can see live metrics about how many operations, how many requests is that currently doing, what's the latency of those requests, so we can start to see if there's any big spikes, and then how all of our other services are responding to. So at the moment, because I sent all of our traffic just to v1, we're only seeing v1 being responded to. But if we started shaping and shifting that traffic, we'd see how all of the other traffic would be faring. And we can drill it into these dashboards and actually see more operations, more insights. So we can see the requests coming in. So when I started that load generation command, we saw that huge spike. So like, this is great. If you follow Troy Hunt on Twitter, this is generally when I've been pwned had been mentioned on TV. He sees something similar. And we can actually now see how our service is responding. We can make sure that all of the requests are being successful, so making sure that everything is healthy. But if we start seeing errors, then we can respond and drill into that accordingly. And obviously, if we now stop my beautiful load testing tool with a few attempts, then we'll start to see the traffic drop off and the traffic die down. And this is all being generated because of how Istio is connected within our system. So our applications don't need to be modified, they don't need to be tweaked or changed in any way to get all of this data. It's just because Istio is at that proxy level, and so it can start collecting and pulling out these insights and metrics. But we can actually go deeper than just high-level metrics. We can actually see how our applications are working and how certain requests are being handled. So this is Vega. It's part of a broader open tracing initiative. And this gives us a per-request level insight into what our application is doing. So for example, we can see all of our incoming requests to our product page service. We can see how long they're taking, so we can identify outliers, like is that user complaining that something's slow, actually, is that because it really is slow, or is that because they just have a slow network or something? Is it us or is it them? And we can give real insights and real responses about how that system is now behaving. And then we can drill into these spans, these traces, and see what our system actually did. So we can see our request coming in to the product page, and then the product page went off in this case and called review details service. That took 2 milliseconds to respond. It then went off and called reviews, and again, only took 2 milliseconds. But if there's a problem, then we'd see that data, we'd be able to identify, like, cool, details actually takes 10 milliseconds or 1 second sometimes, and then you can start drilling into why that happens. Is it a particular service? Is it a particular server? Is it a particular SQL query that sometimes fails at 3 a.m. every morning? And this gives you ability to know why certain things happen and debug that when it occurs. So that's kind of the principles. So if we start looking at how we can shape traffic. So as I was saying, we have these capabilities. So we can start shifting and shaping traffic to meet our needs. So in this case, what we're going to do is the team's successful with version 3. They're happy that it works in development, so now they want to start rolling it out to production. So in this case, they're going to go with 50-50 traffic. So we're going to say that when something comes in to our reviews, set the for HTTP, set the destination to be v1, or set the destination to be v2 with a weight of 50-50. So very similar to how you can set weights in something like Nginx or HA proxy. In here, all we're doing is configuring the weighting of Envoy, which is the proxy in place. So now, as long as we're signed out, we can do some requests. It's happening in a random way, so it's not round robin, it's just random at scale. That works in the same way, but we get some oddities. And so now we can start testing to make sure. Within our dashboards, if we look previously at the home page, again, we now can see the metrics based on what's happening. So previously, it was just a v1 service, but because we started shifting some load, we can now see that v3 is getting some requests, and everything is happy. If v3 wasn't quite as reliable as the team wanted it to be, we would start seeing our dashboard potentially having longer request durations if it had a performance regression, errors not being quite 100%, and we'd be able to start seeing that within our dashboards and then roll back or adjust the application accordingly. And then when we're happy, once we are confident that everything is in place, we could again change our review, change our virtual service for reviews, say like now send all of our traffic to v3, and then what we'll see is we should only see our red services being responded to. So within seconds, we can get this more tighter control about how our components within our system are communicating. So that's how we can start shaping traffic within our system. And this works and operates because of how the components of Istio have been put in place. So because we have this proxy, which can communicate between our components, and we have this mixer, we can have control about how our network is being shaped, which services can communicate, and what percentage of that traffic, for example, could do. And as all of our services are communicating, they're pushing data down into the mixer, and then that's being collected by Prometheus, which we're then displaying with our beautiful dashboards in Grafana, which all come out the box and available to us, plus all of the tracing metrics from with Vega, etc. So to give some more insights into these core approaches and these core technologies that we're building upon, so Envoy proxy, which is kind of the proxy which manages the communication between services. So as I said, it's developed by Lyft. They use it for all of their traffic, and that's a great reassurance because they have a significant amount. So we know it's been battle-hardened and tested, and it's at the heart, at the core of Istio. And it's deployed alongside every single service within our deployment, and it's there sitting as a sidecar within the same pod. We have the mixer, which is saying controls control, usage, collects metrics, telemetry within our systems. We have the pilot, which is managing service discovery, making sure that if we say we want to talk to the review service, then we know how to route there, we know how to get there. If we have to deal with canary releases, then the pilot is there configuring and making sure everything is happening. And the pilot is responsible for resilience, which we'll get into in a moment. And then finally, the Citadel, which is ensuring that everything is secure, the services have certificates, those certificates get rotated, and that all handles for us without us having to manage a CI provider or dealing with something like Let's Encrypt. And then we have this beautiful diagram. So now we want to start dealing and deploying with confidence. So we've seen canary releases. So we can control how that canary release looks. So what we were able to do was we can manage traffic with a weighting, which is what I demonstrated. So having this 50-50 split or 95-5% about how you want it to do. And then that proxy, when traffic is leaving, it will direct where the destination should be, and it will send traffic to a different pod based on the version which we want. But we can also do it based on users, based on the HTTP request. So for example, we saw this for the user agent, or like user being JSON, can do it on a user agent, so we can send all of our traffic for iPhone to one new service that we're testing, and Android goes to a different service, for example, depending on how we want to control this traffic. And there's lots of other requests that sit there and allow us to do our canary releases in a safe way and build upon all of those metrics that are in place. But in reality, at some point, we want to make sure that our applications are responding, and if errors do occur, then they are handled effectively. So if we go, and we can do this scenario. So one of the problems with handling failures is generally failures only occur at unhelpful times. They never occur when you're developing the application, or they're extremely difficult to reproduce. And they will occur at 3 a.m. in the morning when everyone just wants to get it back up and running, and then we need to try and learn the lessons at a later date. So with Istio, because of how we've got this traffic shaping capabilities in place, we can start simulating failures. We can start controlling how requests are being responded to, and actually start injecting faults so that we can test how our application behaves, and actually start improving and building on that resilience. So we're just starting Istio, starting Kubernetes, which we can see here. It's just writing all of the configs and the covers, pulling down the required images, and then we can deploy Istio. Which is taking slightly longer. But in reality, it's only 30 seconds, but it feels significantly longer than when you're standing here watching your own product take a long time. Give me a quicker server. There we go. So we now have Kubernetes, we have Istio being downloaded. It's just going to deploy itself. Let's just make sure that that's happy. We have our review service running. We are now in a good place. So we can do get pods and just see everything starting. So that will start in a few moments. So what we're going to do is we are going to control and start injecting some failures. Now we are doing this, let's say, in production. So we don't want to take down everyone. So instead, what we're going to do is just apply it to our rating service. And we're going to do this. So we're going to use this virtual service, again, to control the traffic. So previously, we were modifying which version JSON would see. So if someone was logged in as JSON, or let's say our developer part of the developer, they would be sent to V2. But we're now using and building on that same capabilities, and we're injecting a fault. And what we're saying is for 100% of the time, introduce a fixed delay of 7 seconds. So users will now always see, poor JSON will now always see a slightly worse performance. Oh, cool. Fantastic. Let's not do that. Let's not do that. Okay, so everything's running. Let's deploy that again. See that everything is configured. So we have our review. We'll wait for the product page to be there. And what did I miss? There we go. So we are currently logged in with our users. We have our review service, which we'll deploy and make sure that that's happy. Sorry. So if we log in as JSON, then hopefully, yeah. So JSON is not having a happy time. He logged in, and now he's getting this worse experience, and then after 7 seconds, our application just kind of falls over and provides this unhappy request. Now, we can start to make sure that our application is handling this correctly. Like, do we want the application to wait 7 seconds, but that's not a great user experience? Or do we want it to actually handle something a little bit more successfully? So for example, if our application was actually doing something more complex, this 7-second delay could start building up a backlog. Having a backlog could cause more requests to queue. That could then cause one of our messaging services or our databases to fall over. So instead of causing and polling and waiting for the 7 seconds, we may prefer to kill it a little bit sooner. And this is where we can start to control how the traffic should work. So if we see actually like how does it behave, how does the application behave if other things occur? So like if instead of it having a delay, what happens when our application just falls over completely and returns a 500 error message? So now JSON gets a much better experience. So having a delay, the application couldn't cope. It didn't know how to handle that situation, and it would fall over completely. Introducing actually falling over and failing gracefully with a 500 error message meant that at least we're getting some reviews back. They're not having ratings, but okay, that's fine. At least we're getting some data back. We're having a more positive experience. And if we hid this from the user, they may never know. And so there's different ways that we can do this and different ways that we can control how that works. We can see all of this within the logs. So if we go to the product page, we can start understanding how our application is working. So we can see poor JSON having some outlier requests at the top. So we can drill into these now and going, great, we know that something was going wrong within our requests. Everything else was responding with 1 millisecond. But for some requests, it was taking much longer. We can see actually it was because our review service was taking 7 seconds. So every time it went off and recorded it, it was just having this awful performance experience. So we can see that in reality and actually not blame the service, but kind of blame the service in our blameless culture. But we can also see, like, are there errors? Like, as part of this request, did the user or did that request encounter an error? And then we can see, like, okay, what happened, and start drilling into some details, so pulling some observability and some clarification into how this should operate and how this should work. What we can also do is start controlling how that application works in reality. So do I want to demo this? Yeah, let's just go for it. So we can start introducing circuit breakers. So circuit breakers will allow us to control the traffic within our network, and if certain things are occurring, gracefully handle that situation. So if an application started to fall over because it was taking too long, so indicating that it was about to fall over, or it started sending 500 error messages, a circuit breaker will handle that and shift the traffic elsewhere. So either shift it to another service, shift it to another version, or handle the situation based on what we need to configure. And so the system will then start to protect itself and start to alleviate some of the risks without our applications needing to code for that situation or without us having to handle it accordingly. So let me just close some tabs so I don't get too confused. And so as I was nicely defined within the quote, so a circuit breaker is critical for distributed systems, and this allows us to fail quickly. So where before that 7-second delay was actually having a negative impact, it meant that the user was never seeing any reviews, with a circuit breaker, we could say, actually, if that service is starting to slow, always kill the requests, always send a 500 error message back, because we know the application handles that in a more graceful way. And we can fix that at a production level without having to change our application and code for that situation. For some reason, that server is particularly unhappy, so I'm going to try something else. So I have a catacoda or it's Wi-Fi, so let's wait for that to start. Oh, great. Okay. For some reason, I can't find a cluster which is already running, so I can't save some time. But I can show you how the circuit breaker will operate. So, there we go. So if we look at our HTTP bin rule, I'm not going to jump ahead, that's confusing. Cut samples, Istio samples, Istio hasn't finished downloading. Istio has finished downloading on this one, so let's bring that. So I'm now deploying a new service called HTTP bin. So this will just output us some nice responses, but this is a service which isn't particularly, let's say, in my situation, the service can't handle scale particularly well. So we know that if it goes over a certain number of concurrent requests, it's going to fall over. So we can handle this more gracefully and ensure that that doesn't happen. So when we try and access it, once everything has started, just watch that and watch the pods. So the product page has been started. Can wait for our sleep to begin. So now we have something that we can send requests to, and we can curl and say like, maybe I didn't even start it. I did run it. It's just everything's operating slightly slower than what I'd want. Okay, let's just skip that demo. So actually, no, let's not skip that demo. Let me show you what's important. So we can apply this, we can apply this. So we can. So within our routing, in a very similar way to how we used a virtual service to manage control and shaping of like injecting faults or canary releases with 50/50, We can control actually how many connections, for example, should our service have at any one point in time. So in this case, we can say there's a connection pool, and we can only ever have a maximum of one TCP or one HTTP connection at any point in time. It's particularly a very poor scaling, but like we're at least protecting the application from falling over. And so what happens is that when that comes in, Istio is managing that layer of complexity and ensuring that our connection poolings are adhered to. So we can make sure that we don't overwhelm a system within our capabilities. What we are also doing is having an outlier detection. So as I was saying, we've got all of this monitoring capabilities in place. So if our proxy is starting to see errors, it knows how to handle that accordingly. So if we see more than one error occurring within 1 second, then stop sending traffic to that particular pod. And so now we can start protecting our system and give it time to breathe, give it time to recover, and actually back off from a production traffic load point of view. And then, if our service recovers, we can then start sending it traffic. So as part of the service breaker, it will, after this, after the back off and the time which we have specified retires, or like expires, there we go, Istio will continue or start to drip feed traffic to this pod which was previously erroring. If it continues to error, then again it will back off and stop sending any traffic to it. If it succeeds, then it will pull it back into rotation and continue to send it traffic until it sees errors again, and then it will continue to back off if it's still unhappy. And so now our system is starting to be able to protect itself and automatically correct errors that are occurring within our system. Our applications don't need to handle this, they don't need to code for it. Instead, we're letting the infrastructure do what it does best, which is manage the flow within our system. And so what this means is that when things start to go wrong and we have lots of things happening, instead of us having to try and debug and identify particular problems within our systems, Istio is knowing that information for us and based on pre-configured rules, knows how to handle it accordingly. And then that combined with the metrics and the visibility and the dashboards gives us insights into how the health of our system is working. It gives us the tracing capabilities so we can go in afterwards and look exactly what the requests were, exactly what services were involved in that request, which caused the problems, and then being able to correct it going forward. So we have all of this capabilities to ensure that our system is behaving correctly. But certain times, it doesn't behave correctly due to malicious actors and security problems. So what does Istio have in place to ensure that? So we've already talked about mutual TLS. So being able to ensure that the two services that we're talking to are the ones which are meant to be talking to. And again, because we have Envoy, we have this proxy in place, this handles all of that complexity for us. The envoys within each pod talks to each other, handles the TLS termination, and then all of the traffic gets pushed back into the service, which is sitting in the same pod. We have the cluster CA, so that's managing all of the authorization, of generation of certificates, rotations, etc. We can start controlling security boundaries within our application, so making sure that our website, for example, can't talk to a database. We already have this within Kubernetes with network policies, but Istio can take that a step further and provide more control and more capabilities, building on top of the foundations that we've previously seen. But basically, this means that we can start building up foundations within our application. And for even greater control, we can start controlling the egress, i.e. the outbound traffic from our applications. So in this case, for one of the default rules is it blocks all outbound egress, i.e. our systems can talk to each other within the context of an internal system, but they're not able to go off and call, upload data to nasty service, which is doing some scraping of our data because they've got hacked, or being able to upload our database to an external service. So all of the traffic remains within our cluster. And what this means is that if our application needs to talk to like a Google API, we can just whitelist, yes, you're allowed to talk to the Google APIs, but you're not allowed to talk to the entire world. And in reality, this makes perfect sense within a containerized system. Like, there's no reason for our containers to go off and talk to apt-get to do some updates or install additional packages, because that should all be done at build time. That's when we build an image, it should be then frozen and not need to be modified. So by default, allowing potential hackers to install additional packages gives them scope and room to have more damage than what they would before. If they can't even talk to the outside world, then there's very little that they're going to actually be able to do and inflict and cause damage within your system. And so this is kind of where having these additional layers of control gives us a lot more security and protections than what we have currently with just deploying on top of Kubernetes. And as I said, Istio isn't the only approach. There's various different service meshes available. I really like Linkerd. It comes again with lots of visibility, lots of controls and metrics out of the box. Operates in a very similar fashion, and it's definitely worth investigating. If you're interested, then there's a catch code scenario on how that works. And you should also explore console and Aspen Mesh too. So where are we? So what are the key takeaways? What are the key points of view? So a service mesh is all about removing all of these infrastructure level concerns from our application, trying to push down retry logic, what to handle when errors occur, how do we shift traffic and perform canary releases so that our applications can focus on their job and we focus on their responsibility. By having it as a dedicated layer, it gives us more control. It gives us a consistent way to control how our systems are communicating. If we want to do canary releases, we have a consistent fashion. We have a consistent way to define the weights, define how we update those and roll those out, without every single component having a slightly variation, a slightly different framework that they're doing in order to be able to manage that. Because we have more control, we have more security. We can define boundaries much easier, much more distinctly at an infrastructure level concern, and instead of relying on higher layers in order to take care of that. But at the moment, it comes at a cost. Like, it does add another layer. It adds another level of understanding that you need to have as a team. It adds another level of complexity, which over time, I'm sure will decrease. But that's something which you need to judge whether this is right for you, whether your concerns match and align. And if it does, amazing. If not, then maybe Kubernetes is good enough at the moment. But these are the tools which are available. Over time, we're going to see Istio as just a tick box inside of things like Azure and GKE and make it much easier to manage. So it's definitely here to stay. It's definitely going to be a key part of the Kubernetes ecosystem going forward, and now you can decide whether it's right for you to pick and choose. So if you want to learn more and you have more time than standing in front, then you can wait for the Kubernetes clusters to start and try it for yourself at katacoda.com. And with that, I'd like to thank you for attending, and now we can all go off and have lunch. Thank you very much.